Hello friends, this question is from the test series number 10 from EDC. Topic name is PN junction theory and characteristics. It's a linked data question. In the problem, we have one parallel combination of diodes in which diode D1 is made up of a germanium whose has a cut-in voltage of 0.2 volt and incremental resistance as 20 ohm, whereas diode D2 is formed of a silicon which has a cut-in voltage of 0.6 volt and incremental resistance as a 15 ohm. The question says that find out the magnitude of current flowing I1 through D1, which is I1, and find out the magnitude of I2, which is the current flow across D2. Right? So we need to find the value of I1 and I2. So let's first of all let's draw the equivalent circuit diagram of the circuit, because we know that my diodes are not ideal; they are basically practical. Where D1 is made up of a germanium, so my circuit will be like anode terminal is always positive, cathode is negative with the increment resistance. Okay, increment, and the other is a silicon. Similarly, anode positive, cathode negative with the incremental resistance. And there we have a supply battery. Okay, there's a connection. So here we know that my supply battery is of the 100 volt, right? And the cut-in voltage of the germanium is 0.2 volt. Incremental resistance for the germanium is 20 ohm. Cut-in voltage for the silicon is 0.6 volt. Incremental resistance is 15 ohm. And the direction of the I1 is this. Direction I2 is this. And we need to find the value of I1 and I2. Let's name this node as a node A. Right? So voltage across node A will be VA. So if I can assume the current I, total current I, where I must be equal to the I1 plus I2. So my I1 plus I2, which is equal to I, is will be 100 minus VA upon 1000 or 1K, right? It's the, because the across the 1K resistor we have a one battery 100 volt and the VA terminal, A terminal, which has the voltage of VA. So my I1 plus I2 is equal to the 100 minus VA upon 1000. We know that in parallel the voltage outlet remains same in the parallel, and so the in both the path of the diodes across the germanium or across the silicon we have the voltage of VA. So we can write down the two equation. My VA is must be equal to zero point 0.2 plus voltage drop across incremental resistance 20 I1, and then for the silicon VA is equal to 0.6 plus voltage drop across the incremental resistance 15 I2. So my first equation is equation number 1. If I can name the second equation as equation number 2, in the third equation number 3, you can see that in all these three equations we have a three unknowns I1, I2 and VA, right? So we have a three unknown and three equations, so I can simply find it out. So by simplification, my I1 is equal to the 53.7 milliamp and my I2 is equal to the 44.9 milliamp, right? So this is my answers. So my correct option is, so it's a, there is no options, it's a numerical value question. So my value of my I1 is 53.7 volt, same milliampere, and my value of my I2 is 44.9 milliampere. Thank you.